So good morning everyone and welcome to this lecture.
Good morning, sir.
So in this what we are going to do in this lecture, this is first lecture in which we are going to discuss collision. Let us go back and see what we had discussed in the previous class. In the previous class we had discussed the concept of impulsive force. Yes or no? Now these forces which are impulsive, there are very specific type of forces which act for a very short time, but they are forces of very large magnitude. We had discussed that, yes or no? And we had also seen that these impulsive forces, gravitation and spring force, are not taken as impulsive during what we call as collision. But other forces such as normal reaction, tension, and friction can be impulsive and can be non-impulsive at times. Do we understand this? Now, depending on the scenario, forces which are normal reaction, friction can be impulsive as well as non-impulsive. I can just show you some examples of impulsive. Oops, what has happened here? I can show you some example of forces when they are impulsive and you will be able to understand when are these forces going to be impulsive and when are these forces not going to be impulsive. So as I said, some forces are dependent on case. Now sometimes normal reaction can be impulsive. Sometimes normal reaction may not be impulsive. For example, if two bodies are colliding like this, body number one and body number two, they're colliding like this, then these normal reaction between these two bodies is actually impulsive. Because of this, things are going to happen. But the normal reaction from ground here are non-impulsive because they are not going to change the momentum of the body drastically. Because of this, only the momentum is getting changed. Therefore, in this case, the normal reaction which is coming from ground is non-impulsive. Do we understand this?
Yes, sir.
Now, if you can draw this diagram if you want to, or you can just listen to it. If you look at this diagram here, if a ball is kept and the other ball is falling from top, in that case, what happens? Both the normal reaction, whether it is between the balls, this normal reaction, or the normal reaction coming from ground, both are impulsive in nature. Because of this normal reaction, the momentum is changing or they are not allowing momentum to change. Do we understand this? Do we understand this? Yes or no?
Yes, sir.
Okay. Now we will look at the third diagram and you can see in which force is impulsive and which force is non-impulsive. Can you tell me in the third diagram which force is impulsive and which force is not impulsive? This one is diagram number 1, this is diagram number 2, this is diagram number 3. In diagram number 3, can you tell me which force is impulsive and which force is non-impulsive? You can see three types of normal reaction. One type of normal reaction is between the two bodies. Then there is a normal reaction coming from ground, the yellow one. Then there is a normal reaction coming from ground on the smaller body, which is N3. Which of these normal reactions are impulsive and which of this normal reaction is non-impulsive? Remember, impulsive forces will change the momentum or will stop the momentum from getting changed. Non-impulsive forces will not do anything of this nature. Look at the diagram and tell me which force do you think that is impulsive in this case? Normal reaction number 1, is it impulsive or non-impulsive?
N1 impulsive, sir.
N1 impulsive. What about N2?
Non-impulsive.
Very good. What about N3?
Non-impulsive, sir.
No, N3 is impulsive. Why is N3 impulsive? Imagine if this ground was not there, then what would happen? When this ball pushes this ball should move here. But this ball is not moving here. Something is stopping it. What is stopping it? Is this normal reaction. Do we understand this?
Yes, sir.
Look at the normal reaction N2. The normal reaction N2 is like this. When this ball hits it, this normal reaction is keeping it on ground, but it is not going to go on ground. It is actually, the bigger ball is actually wanting to fly away like this. Yes or no?
Yes, sir.
It can fly away. Normal reaction is not stopping it from flying away. Are you getting my point?
Yes, sir.
So the normal reactions here which are impulsive are N1 and N3 are impulsive. N2 is non-impulsive. Do we understand this?
Yes, sir.
This is how you can find out which normal reaction is impulsive and which normal reaction is non-impulsive in nature. One more example here. Example number 4. What happens in example number 4? Which reaction is impulsive and which reaction is non-impulsive? N1 and N2.
N1 impulsive, sir.
What about N2?
Impulsive, sir.
Both of these normal reactions are impulsive. This is because of the impact, and this one, if this ground was not there, this ball would have crushed down, but it's not crushing down. Something is stopping it. That means both the normal reactions are impulsive. I hope you have understood this concept. Yes or no?
Yes, sir.
Now, when you talk about friction, what happens with friction? Now, friction comes with the normal reaction. Yes or no? Friction is mu times normal reaction. Yes or no?
Yes,
So
sir.
that means it depends on the normal reaction. If the normal reaction is impulsive, then friction, which is coming from that normal reaction, would be impulsive. If normal reaction is non-impulsive, friction coming from that normal reaction would be non-impulsive. Do we understand this?
Yes, sir.
So if you look at this diagram again, now here in this diagram, both the normal reactions N1 and N2 are impulsive. Yes or no?
Yes, sir.
Therefore, friction between ball 1 and ball 2 and ball 2 and ground, both of the friction would be impulsive. Do we understand this?
Yes, sir.
Looking at this one, looking at the next diagram, this one, here we know N1 and N3 are impulsive. So friction because of N1 and N3 would be impulsive. Friction because of N2 would be non-impulsive. And do we understand this?
Yes, sir.
Okay. Now we move on to impulsive tension. I hope you have understood the concept of impulsive.
Yes, sir.
Okay, now let us talk about impulsive tension. So you can write the next heading, impulsive tension. When is tension going to be impulsive? Impulsive tension. Now you look at these three positions. Now, first of all, if you talk about the normal reaction in case number A, in the normal reaction in case number A would be impulsive, yes or no?
Yes, sir.
In case number B, normal reaction is also impulsive. In case number C, normal reaction is also impulsive. If you talk about the tension in the case of collision A, B, and C, in which case The answer is already there on the screenshot. In which case is the tension impulsive, and what is the reason for it being impulsive? You can see in case number 1, the tension T is impulsive. In case number B and case number C, tension T is not impulsive. Can you tell me why it is impulsive? This this is tension of the string. In case number A, as you can see, is impulsive. In case number B and C, it is non-impulsive. Can you tell me why it is non-impulsive? In case number A, when it hits, this ball is supposed to go here like this, but it cannot go because the string is stopping it. Therefore, string must give impulsive tension, that is cancelling the impulse which is given by impulsive normal reaction which is given by ball number A. In case number 2, the ball wants to move this way. The string is not going to stop it from moving this way. So it is not cancelling the impulse. In case number 3, when it hits from below, when it hits like this, the ball tends to move like this. It can always move like this. So tension is non-impulsive. In case number 2, the ball hits like this. It wants to move like this. It can move. It is non-impulsive. In case number 1, the ball hits like this. It wants to move like this. It cannot move. That means the tension is impulsive. Do we understand this? Yes or no?
Yes, sir.
So this is how we can find out whether the tension is impulsive or not. I'll give you 2 minutes to note this down. Once you're done, please let me know.
Done, sir.
Then this question, sir. You talk about impulse. This is the question. Let us do it first. One-dimensional force varies with time according to the given graph. Calculate the impulse of force in the following time intervals from 0 to 10, from 10 to 15, from 0 to 15. And I'll give you 5 minutes or 2 minutes to do this, not 5. I hope you remember force, time, impulse. Yes or no? Okay.
Hello, sir.
Yes, beta.
Sir, here from 10 to 15, its force is not given, no, sir. Coordinate of force.
Yes, 10 to 15, the coordinate of force is not given. Let me check. It's not given. You don't have to find it out. You can't find it out? Do it.
Sir, it's done, sir.
Yes, bacha, got the answer?
Yes, sir. A is,
See?
A is 75 newtons.
A is 75 Newtons second, not Newtons.
B is 25 newtons.
Array, the unit is wrong. Impulse cannot be in Newtons. Say the answer again.
Sir, 75 newtons, sir.
What are you calculating? Are you calculating force or are you calculating impulse? Are we calculating force or are we calculating impulse?
I am calculating impulse, sir.
What is the unit of impulse?
Newton seconds, sir.
Yes, that's correct. Now give the answer again.
75 newton seconds.
First case, okay.
25 newton seconds. Third one is 15 newton seconds.
Impulse is a vector. So it must have some magnitude, it must have some direction. If it does not, if you can't tell me direction, you must say positive or negative. Try the answer again. What is the answer for the first one? Plus 75 Newton second. Do we understand this? What does this plus sign indicate?
Positive.
Direction, not positive. It indicates direction. Do we understand this?
Yes, sir.
What is the answer for the second one?
Minus 25 newtons.
Good. Minus indicates
Direction.
direction. Good. Third one.
Plus 50
Plus 50 Newton
second.
second. Plus indicates
Direction.
good. Everyone got this answer? Yes or no? So coming back to your question, this is not given. How did you find it out?
Similar triangles.
Similar triangle. So use your brains. Physics is nowhere. It's only maths. Which is also not maths. This is basic common sense. This angle, this angle, this side, this side, this side, this side. Similar triangles. Remember, if you are not good at maths or you miss, this is not maths, this is pure, simple geometry. Geometry is not, I don't call this geometry as maths. This is common sense. We all see geometrical figures around us. Everything is geometrical. Everything that you see is geometrical. You must be able to understand this. Do you understand this, yes or no? Shall we move ahead? Huh? Okay. Now the next heading is impulse momentum theorem, and we have already done this. The only thing is we did not write it in this way. So we will go back to the past and look at this point. When we had written this statement, impulse is the change in momentum. This statement is known as impulse momentum theorem. Whenever we have an impulse acting on a body, the momentum of the body would change. This is known as impulse momentum theorem. Do we understand this?
Yes, sir.
Okay. Now, from here, you can also write this small statement. If impulse is zero, which implies that the force acting on the particle is zero, which implies that the change in momentum of the particle would be zero, which implies that the momentum of the particle or the system will remain constant. So this last line becomes which theorem? The last line which is written in yellow. The first line that I wrote, the first green one that I wrote was impulse momentum theorem. Then what is the yellow one that I have written? We have already discussed that. Yes, bacha.
Yes, sir.
What is the yellow one? Known as huh? What is the yellow one known as?
Sir, we can't understand. What are you saying?
The yellow statement. Please, can you read the yellow statement? What does that statement mean? You can't read that statement?
Yes, sir.
What does that mean? What is that known as?
If impulsive force is zero, force acting external is zero, and change in momentum is also zero, which implies
Which implies
momentum is conserved, means constant.
momentum is conserved. So what is this statement known as? This statement is known as
Impulse momentum theorem.
this is known as law of conservation of linear momentum. A force acting on a particle is zero. The external force acting on a system is zero. The momentum of the particle remains constant. That is known as law of conservation of linear momentum. We have done it. We have done questions on it. I hope you remember it. Do we remember it now?
Yes, sir.
Okay, thank God that we remember. This is known as law of conservation of linear momentum. The force, net external force acting on the particle is zero. The momentum of the particle remains constant, or the momentum of the system remains constant. Now I have tried to make you understand the same thing, not by using force as zero, but impulse as zero. It means the same thing. If impulse acting on the particle is zero, implies that force acting on the particle is zero, which will imply that the momentum change of the particle will be zero, which will imply that the momentum of the particle remains constant. That becomes your law of conservation of linear momentum. Do we understand this? Yes or no?
Yes, sir.
So then I can have a mother-daughter relationship again. We had a one mother-daughter relationship before in the last chapter. Do you remember that mother-daughter relationship? Do you remember that mother-daughter relationship we had in the last chapter? One was mother theorem, one was daughter theorem. Do we remember it?
Yes, sir. Work energy theorem and lock me.
They were mother and daughter. Who was mother? Who was daughter?
Work energy theorem is mother and lock me is daughter.
Why is work energy theorem mother theorem? Because you can apply it anywhere, whether the forces are conservative or whether the forces are non-conservative. Yes or no?
Yes, sir. Yes, sir.
Why is the Locke-May law of conservation of mechanical energy? Why is the daughter theorem? Because it can only be applied
Only on conservative forces.
here. This one is the mother theorem. This mother theorem can be applied whether impulse is zero, you can apply it. If the impulse is not zero, then also you can apply it. And this one becomes the daughter because it is a special case of the mother theorem. Mother theorem says that whenever impulse is there, impulse is change in momentum. If impulse is zero, then comes the daughter. So this daughter theorem can only be applied where the force or the impulse is zero, but the mother theorem can be applied everywhere. So whatever questions we had done with law of conservation of linear momentum, the same question could have been done by impulse momentum theorem. Do we understand this?
Yes, sir.
Why? Because impulse momentum theorem is valid always, whereas your your Locke-May is only applicable when the net force or the net impulse acting on the body is zero. Is it clear to everyone? Yes or no? No, yes.
Yes, sir.
Pakka? So don't forget this mother-daughter. One more mother-daughter will come. Two more mother-daughter will come. They are not different mother-daughters. They are same mother-daughters, but they will be applied in the next chapter. Comes this question. They are these days giving questions on graphs. So it's good if you can do a lot of question on graph. A box of mass 2 kg is resting on a frictionless horizontal ground is acted upon by horizontal force F, which varies as shown. Find the speed of the particle when the force ceases to exist. You have 2 minutes to solve it.
Sir, it's done, sir. Hello, sir.
Yes, bacha.
Sir, it's 20 meter per second.
Is 20 meter per second. Let me check. Yes, that is the correct answer. Good. How did you get it?
Sir,
Sir?
area under force and time graph is impulsive force, which is change in momentum. Sorry.
Try again. Area under
Force and time graph.
is
Impulse.
impulse,
That is
not
equals to-
impulsive force.
Okay, sir. Impulse.
It's not impulsive force. Impulsive force is force. Impulse is force into time. You understand this?
Yes, sir.
Good. This force is impulsive force. But area under force time graph, this is impulsive force because it is creating an impulse. So do not mix these terms, impulsive force with impulse. Impulse is force multiplied by time. Impulsive force is just a force. Okay. So the area under this graph, what is the area under this graph? Half into base into height. So how much is the area? 40, yes or no? 40 Newton second, yes or no? Huh? So that must be equal to change in momentum. Final momentum is m into v. Initial momentum, it was at rest. Initial momentum is 0. So the final velocity is 40 multiplied by 2. Answer is 20. You should call it plus 20 because everything is a vector here and plus indicates the direction. Do we understand this? Yes or no? Impulse momentum theorem. Impulse momentum theorem. Mother theorem. Daughter theorem. Okay. That takes us to the next heading, and the next heading is collision. So we write the next heading and we will write collision. Now, what do you mean by collision? What do you mean by collision? Write the next heading. What do you mean by collision? Yes. What do you mean by collision? Anyone? Any idea? Collision. What do you understand by the term collision? No one understands the term collision? There is a body of mass m1 and there is a body of mass m2. This body of mass m2 is moving with a velocity v. You can see me, yes or no? So there are two bodies. Case number 1, body of mass m1 kept on ground, body of mass m2 hitting it from the side. Second case, there is a body of mass m hanging here, m1 hanging here like this, a body of mass m2 striking it like this. Case number 3, there is a wedge of mass m1, all are frictionless, and there is a wedge on that wedge of mass m, and then there is a block of mass m2 kept on top of it, and I leave the system. Then this is earth and this is moon, and moon is moving around the earth in a circular orbit. We know this. Case number 4. Case number 5. This is a man. He looks like an alien. Anyways, he has a bat in his hand. The bat looks awkward, and he is hitting a ball coming from here. My diagram may not be promising, but they serve the purpose. Case number 5. This may be a racket, may not be a bat, and this may be shuttlecock. Doesn't matter. Okay. 1, 2, 3, 4, 5. Which of them is a collision? Which of them is not a collision? Huh?
So 1 and 2 are collisions.
1 and 2 are definitely collisions. No problems. Yes.
3 and 4 are 3 and 4 are not collisions.
Okay. 3 and 4 are not collisions. 5. Batsman hitting the ball.
Yes, sir. It's also collision, sir.
It's also a collision. Everyone thinks the same. 1, 2, and 5 are collisions, and 3 and 4 are not collisions. Yes or no? Well done. That is in fact the wrong answer. All of them are collisions. Actually, all of them are collisions. All of them are collisions. What do you mean by a collision then? All of them are collisions. Surprised, no? All of them are collisions. They may be thought of as different kinds of collisions, but all of them are collisions. So what is a collision? Whenever two bodies are interacting with each other, whenever two bodies are exerting any force on each other, they are actually changing the momentum of each other. Now, they may exert force by actually coming in contact, which is happening in the case of 1, 2, 3, and 5. Bodies are actually coming in contact and exerting force on each other. In case number 4, they are not in contact. You can make case number 6 as well. 5 space here. Case number 6. We have one magnet, north and south. We have one more magnet, south and north. This is also a collision. Case number 6 is also a collision. Now, what is different between case number 1, 2, 3, 5, and 4 and 6? In case number 1, 2, 3, and 5, they're actually coming in contact and then exerting force on each other. In case number 4 and 6, they are not coming in contact, but still they are exerting force on each other. All of this are collisions. So collision is nothing but an interaction, an event, or a process in which two bodies exert force on each other, they affect each other, and they start to change the momentum of each other. Do we understand this? Do we understand this? So all of these 6 things are collision. So what is a collision? What is a collision? In short, what is a collision? A collision is an event or a process in which bodies, either by coming in contact or due to mutual interaction, affect each other's motion. They change the velocity, momentum, energy, or the direction of motion. This is collision. In short, this is the best definition of a collision. Mutual interaction between two particles is defined as a collision. Whenever we have two particles interacting with each other, that process, that event, that interaction is a collision. Do we understand this?
Yes, sir.
That is a collision. So what are the things that you need to remember about collision? Number one, it is interaction. Interaction between two bodies. Number two, physical contact is not necessary. They can remain away from each other, still we call it collision. They change the velocity or momentum of each other. Do we understand this? Momentum or the velocity of the particles are changed. In fact, we can say that collision is a redistribution of the total momentum of the particle, and this is the best way to understand collision. This is the best way to understand collision. Collision is a redistribution. Collision is a redistribution of the total momentum of the particles. The momentum of the particles get redistributed in a collision. Do we understand this?
Yes, sir.
Now, give you 2 minutes to write this and then we'll go back to the diagrams.
Done, sir.
Everyone understood what we have written here?
Yes, sir.
Okay. Now, this is the broader definition of collision, and in this definition everything comes under collision. Wherever there is a force acting between two bodies, that is a collision. Now let me go back to the original diagram. This was the original diagram. Now out of these type of collision, we are going to just take some collision out and discuss the rest, because the other collision we have already discussed. We have already done this question where we had seen this particle comes down, this goes away. We had seen what is the distance traveled, what is the displacement of each particle. Yes or no? We done the question. Yes or no? This is force between two magnets. We will discuss it in the chapter on magnet, bar magnets and all that. This is earth and moon, gravitation, again a collision, mutual interaction, mutual forces, gravitational forces. Here it was gravitational force, here it is magnetic force. We will discuss them. Now let us go back to what is remaining now. Now what is remaining? Let me take out this one. This is gone, this is gone, and this is gone. Now we are remaining with the three types that are there: 1, 2, and 3. 1, 2, and 5. Now, out of this 1, 2, and 5, they have something very common about the two. All these, not two, there are three. All these three have something very common. What is that common thing that you see between these three, 1, 2, and 5? which we are going to study now under this heading. Yes. What is the common between the three? 1, 2, and 5.
Sir, bodies are in contact, sir.
Yes, there had the common thing is there is an impact. There is a sharp impact here in 1, 2, and 5. Okay. So whenever there is an impact, this impact is of very short duration. Yes or no?
Yes, sir.
They come in contact with a very short time. But in that short time, forces of very large magnitude acts for that short time. What are that forces known as? That forces are known as large magnitude force acting for a very short interval of time. What are those forces known as?
Impulsive forces.
So in all the three cases, 1, 2, and 5, the common thing is they are coming in contact. Number one, there is an impact and there are impulsive forces acting on this. So we will concentrate ourselves on these type of collisions where there is a sharp impact. Okay, that is why it is better to write it as impact. So now what all things we need to remember about these collisions? The collisions where there is an impact. What are the things that we must remember about these collisions? Yes. Important points. About the collisions that we are going to study. Number one, there are going to be a sharp impact. Sharp impact. Time of impact or collision. We call that time as delta t. Time of impact or collision is very small. Do we understand this? Large forces and what are these large forces known as? Which are impulsive in nature. Large forces will act for a very short interval of time. Remember, gravity and spring forces would be neglected. Why are gravity and spring forces neglected during impact?
Sir, because they will act for a long time. Sir, we want
Yes.
2 minutes of time. We are shifting the room.
Okay.
Just 2 minutes. Sir.
Yeah, shift. I'll wait. Okay, then what we were discussing? We're discussing the important points about the type of collision that we are going to discuss. They are going to be a sharp impact. The time of impact is going to be very small. Large forces, impulsive forces are going to act for a very small impulse time interval, and forces like gravity and spring are neglected because they are going to be negligible. Have you noted it down? Note
One.
it, note it down and let me know. Then I'll give you an example to show why it happens. Because everything, if it is said in terms of an example, it might make more impact. Okay, so I'll give you a minute. Note it down and then let me know. I can't see you, so please let me know.
I can't see you.
No, I can see you. Sorry, the camera. I switched the camera off. I can see you. Okay.
Okay, sir. Done, sir.
Okay. So we move ahead, and we have written that this gravitational force is not very impulsive. Let us try to understand it with an example why it is moving. Okay, let me take the example of this type of collision. This is ground, a body, a ball is falling. It hits the ground with a velocity, let us say 2 meters per second. A very simple example. I could have made this question more promising by, instead of giving you this 2 meter per second, I could have given you that it falls from certain height. I hope you understand it. Doesn't matter, you just have to find out the velocity with which it is hitting the ground. After hitting the ground, it rebounds. Let us say we call it elastic collision, whatever, with the same velocity 2 meter per second. So this is the rebounding velocity. Now it stays in touch with this ground because it has to stay in touch with the ground from 0.002 seconds, because you have to understand that the time is very small. Yes or no?
Yes, sir.
Time is very small. Now the question is very simple. Find the impact due to gravitational force, and why is this momentum changing so drastically? 2 meter per second, it is moving downwards. The mass of the ball, let us say, is 1 kg. Let me make it 3 kg, so that why is the momentum changing? Momentum is changing, so there must be something known as an impulse. Who is giving you that impulse? Gravity may be giving you, or apart from gravity, what is the other force which is giving us that impulse? Body is hitting the ground and rebounding back. Who is giving us that? Huh?
Normal force.
The normal reaction. So find the impulse due to gravity and impulse due to the normal reaction, and you will see the difference. Remember, gravitational force is constant, is always equal to m into g. Yes or no?
Yes, sir.
Okay. You have 2 minutes to do this. Shall I help you out?
Yes, sir.
What is the impulse due to gravity? Now the gravitational force.
Zero, sir.
No, it is not zero. I will just write it. Impulse due to gravity. Will it be upwards or will it be downwards? Gravitational force is mg and it is downwards. Yes or no?
Yes, sir.
Multiplied by t. So it will be downwards. Downwards I am going to call negative. You can find out the impulse due to the gravitational force. What is the impulse due to the gravitational force? Mass is 3 into acceleration due to gravity is 10 meter per second square multiplied by 0.002. How much is that coming? Will come very small, right? It will come 0.06 Newton second. Do we
Yes.
understand this?
Yes, sir.
Now let me find out the impulse due to the normal reaction. This momentum is not changing because of gravity. It is changing because of the impulse. Yes or no?
Yes, sir.
So how do I find it? I find by the change in momentum. Now, how do I find the change in momentum? Initial momentum, final momentum is upwards. I call it positive. Yes or no?
Yes, sir.
3 into 6 positive minus 3 into 6 negative. Yes or no?
Yes, sir.
How much is that coming? That is coming 12 Newton second. Now, when I look at this and when I look at this, we can understand. We can understand what? Impulse due to normal reaction is very, very, very large compared to impulse due to gravity. And that is the reason we don't take gravitational force or spring force as impulsive force, because during a collision, these forces are very small compared to the forces that we are dealing with. Do we understand this?
Yes, sir.
So this is an example for you to understand why gravity is neglected, why spring force is neglected, because they are very negligible compared to what is happening here. Okay,
Yes.
I'll give you 2 minutes to note this down and then we'll
Done,
move
sir.
on to the next question. Done? Everyone has noted this down?
Yes, sir.
Okay, then we will move on to the next heading, and the next heading is collisions. When I say collisions, I again refer to the 3 collisions, 1, 3, and 5 that we are dealing with. Now, as soon as we heard the term collision, or instead of collision, I must use impact. Impact would be a better word to use here. Impact between two bodies. Instead of calling it a collision, let me call it an impact. So it's very clear that I'm talking about when balls are doing this. Now I can classify this impact between two bodies into various categories. The first type of impact is known as the first type of basis on which I can classify this impact is central. We can also call it non-eccentric. Or eccentric impact. Have you heard these terms? Huh?
No, sir.
Okay. Now, before going on to understanding this, let us understand something which is known as line of impact. line of impact. What do you mean by this line of impact? Anyone has heard this term, line of impact? Now, line of impact, when two bodies are colliding or having an impact, line of impact is normally the line along which the impulsive forces act on the two bodies. So line of impact, in very short, is the line along which impulse or impulsive forces act.
Yes, sir.
This is the line along which the impulsive forces act. This is normally given by, this is a line passing through normally. This is a line passing through the common normal. This line of impact can be determined by the geometry of the two bodies. This line of impact can also be determined by the direction of change in momentum. Now, having said so many things about this line of impact, let us try to understand how can we find out this line of impact. For example, this is a body. This is a surface and a body of mass m1 is kept on this surface, and a body of mass m2 is moving like this and is colliding like this. So in this case, what will be the line of impact? The line of impact will be the common normal, yes or no?
Yes, sir.
This would be the line of impact. Do we understand this?
Yes, sir.
Let me just take this off. Draw it not as a bold line, but as a hash line. So this line of impact would be like this. Now, if let us say the case of this ball, big ball colliding with a smaller ball, where will the line of impact be? It will be along the common normal. Do we understand this?
Yes, sir.
This would be the line of impact. We understand this?
Yes, sir.
Third example. If there is a wedge, oops. If there is a wedge and a ball is falling on this wedge, and a ball is falling on this wedge, moving with a velocity v, what will be the line of impact? This line would be the line of impact, yes or no?
Yes, sir.
So basically what you can understand from this entire thing is that line of impact can be determined by how the collision is happening, yes or no? Do we understand this?
Yes, sir.
One more example. What you are going to see is a top view. You understand the meaning of a top view? This is the top view of ground. And here we have a ball which is stationary. A ball which is stationary. A ball comes from here, ball 1 comes from here and hits ball 2. Remember, ball 2 is at rest. Okay. ball 1 hits ball 2. After collision, ball number 2 moves like this. After collision, ball number 2 moves like this. Do you understand the scenario?
Yes, sir.
Ball number 1 is moving.
Ball number
Ball
two.
number 2 is at rest. Ball number 1, it's a billiard ball. You must have seen a game of pool or a billiards, right?
Yes,
We have
sir.
this cue ball, the red ball, and we have these stationary balls. And this cue ball hits that stationary ball, and the stationary ball moves in one particular direction.
Yes,
It may
sir.
not move along the same direction always. Yes or no?
Got it, sir.
Okay. Now, can you tell me what will be the line of impact here? Yes. Can you tell me what will be the line of impact here? I've done something.
It's along the red line, sir. The ball too.
Yes, this will be the line of impact because it can only move along that line in which it has got an impact.
Yes, sir.
If it was at rest, it can only move in that direction in which you give an impact. So the direction in which this stationary ball moves will be the direction of the line of impact. Do you understand this?
Yes, sir.
So normally in most of the cases, the line of impact is the common normal. But in some very peculiar cases, if you have one ball stationary, you can find out from the direction of the motion of the second ball, second object, you can find out where is the line of impact. Do we understand this?
Yes, sir.
So this is all about line of impact. Now the heading of this classification was central impact or eccentric impact. Now, what do you mean by this central impact or eccentric impact? We will not be dealing with this we'll not be dealing with this eccentric impact now, but you'll have to understand the difference between the central impact and an eccentric impact. What is this central impact or eccentric impact? So I'll just again write that in. You have seen this now? You have seen the line of impact, yes or no?
Yes, sir.
Okay, so since you have seen this line of impact, what will I do? I will copy this and I will put it here. Now, what do you mean by this central impact or eccentric impact? Now, if your line of impact passes through the center of mass of both the bodies, then what will happen? If your line of impact passes through the center of mass of both the bodies, they will not rotate. They will just have translational motion. Do we understand this?
Yes, sir.
So when your center of mass lies along the line of impact, the bodies don't rotate, they only move translationally. Such type of impact is known as central impact. If the mass centers, that is center of mass of both the colliding bodies are along the line of impact, the impact is called central impact. If any of the center of mass does not lie on the line of impact, then it is known as eccentric impact. Central impact is also known as non-eccentric impact. And you can see the example of central impact here. Do you see this diagram that is coming on your screen now? Here, as you can see, this is the common normal. You see the common normal?
Yes, sir.
This is the common normal or the line of impact. And you can see both the center of masses are lying on the line of impact. In this case, these bodies will not rotate. They will just move in translational motion. Do we understand this?
Yes, sir.
This type of impact is known as a central impact.
Hmm.
You will not find this in any book, so just note this down. This is known as a central impact. The other type of impact will be known as an eccentric impact. What do you mean by an eccentric impact? This is a good example of an eccentric impact. I can give you more examples. This is the example of an eccentric impact. You can see here the common normal or the line of impact is like this. One of the center of masses is lying on it, so this body will not rotate, but the other center of mass lies here, so this body can rotate. This
Yes.
is again an example of
Eccentric impact.
eccentric impact. Do we understand this?
Yes, sir.
But again, you must understand that this definition may have some flaws. Now, let us take one more example and I will again give you the top view of this. This is, you can see a rod. This is the center of the rod. Now, if a mass hits the center of the rod, what type of impact would this be?
Central impact.
This would be central impact. Both the bodies will keep on moving in translation. Yes or no?
Yes, sir.
This is a central impact. Let me call it as CI, central impact. Second case. Same body, M2, and this body hitting it here. What type of impact is this?
Eccentric impact.
This is eccentric impact. Third case. Now what I have done is I have fixed this. Up till now, this rod was not fixed. It was kept on a smooth horizontal floor. It was not fixed. I fixed it, hung it or fixed it. You understand the meaning of hanging or fixing?
Yes, sir.
Again, this is the center of mass of this body M2. Now again, this is hitting it exactly at the center. What type of impact is this? Remember, for this rod, it is eccentric impact because it can still rotate on that hinge. Yes or no?
Yes, sir.
But for this body, it is still a central impact because this body will not rotate. Are you getting my point?
Yes, sir.
So you cannot call it eccentric and centric at the both times. So you will have to call it eccentric impact. Do we understand this? So even
Okay.
though it is hitting the center of mass of this, both the center of mass, they still lie on the line of impact. It looks like, but actually this is not the only line of impact. This board is not free to move. So this hinge is also giving it an impact. Therefore, the line of impact does not lie here. Okay. It looks
Yes.
like the line of impact is along this line. It's actually not along this line because this hinge is also giving it an impact. Do we understand this?
Yes, sir. Got it, sir.
Okay, so this is central impact and eccentric impact. Obviously, we will not be dealing with eccentric impacts now. We will be dealing them only in the chapter on rotation. So we will be now concentrating only on
Sir?
central impacts. Yes, beta.
No.
Anything troubling you?
No.
Okay, so I think we will end up this class here. The time is over. Yes or no? When did we start? We started at 9:30. Yes or no? So I
Yes.
think the time is over. It's 11 o'clock. Okay, so I will wind up here. And in the next class, we will move ahead with the remaining topic. If you have any
Okay.
doubts, you can come up to me. Bye-bye.
Sir, did you send the DPP, sir, of this impulse?
I have sent everything
Okay.
and I have sent it 5 times. I have again sent it to Raghu,
Yes, sir.
sir.
We got it, sir.
I've
Sorry.
sent everything to and for the next topic, I'll send it again. Okay.
Done,
ठीक
sir.
है, take
Thank
care.
you, sir.
Bye.